Hey there fellow coders, welcome back to Code 733Z, where we simplify complex coding concept into bite-sized, easy to digest tutorials. Today we are diving into the fascinating world of convolutional neural network or CNN using TensorFlow and Python. By the end of this video, you will know how to build a CNN to recognize handwritten digits from the famous MNIST dataset. This is the dataset. So whether you are a beginner or someone looking to fresh your machine learning skills, stick around. This one is for you. Let's get started. Before we jump into the code, let's quickly understand what a convolutional neural network is. CNNs are specialized neural networks designed to process and analyze visual data like images. They work by identifying patterns and features in an image through layers of convolution, pooling, and dense connections. In simple terms, if traditional neural networks are like a list of instructions, CNN are like visual detectives, spotting edges, textures, and patterns to recognize images. And today we will use CNN to tackle the MNIST dataset, a classic in machine learning. It contains 60,000 training images and 10,000 testing images of handwritten digits ranging from 0 to 9. Okay. Now let's walk through the code step by step. You can find the full code in the description below. Step 1. We start by importing necessary libraries, TensorFlow for building the model, NumPy for handling arrays, and Matplotlib for visualization. We are also using Seaborn for our confusion matrix and scikit-learn for evaluation matrix. Okay. Step 2. Process data. Next, we process the MNIST dataset. We load the data using MNIST data, load data, and split it into training and test set. To make the data suitable for our CNN, we normalize the pixel values for a range between 0 and 1, reshape the images to include a channel dimension. Finally, we convert the labels into one hot and post format, which is essential for multiple classes classification tasks. This processing ensures our data is ready for training. Step 3. Build the CNN model. The first layer is a 2D convolution layer with 32 filters and a kernel size of 3 by 3 followed by a ReLU activation function. Next, we add a max pooling layer to reduce the spatial dimension followed by another convolution and pooling layer. Finally, we flatten the data and connect it to the dense layers, ending with a softmax activation for classification. We compile the model using the Adam optimizer and category cross entropy losses. Okay. Step 4. Train the model. Training is where the magic happens. Here we train the model on our data for 5 epochs with a batch size of 64. We also validate the model on 10% of the training data to monitor its performance. Once training is complete, we evaluate the model on the test. After training, we evaluate the model on the test set. The model's accuracy on the screen data gives us an idea how well it performs in real world scenario. For this, run our model achieved an accuracy of, you can see the accuracy 0.9894. Okay, not bad for a beginner friendly CNN. To understand the model learning progress, we plot the training and validation accuracy and loss. As you can see, the training accuracy is increased over epochs and the validation accuracy stabilized, which indicates good learning. Next, we plot a confusion matrix to see how well the model predicts each digit. For example, in this heat map, darker shades indicate more accurate predictions for a specific digit. Step 7, make predictions. Finally, let's visualize a few predictions. For each image, we display the predicted digit and alongside the actual digit. As you can see, the model is doing a great job of recognizing handwritten digit. And that's it. You have just learned how to build a convolutional neural network to recognize handwritten digits using TensorFlow. Whether you are a beginner or someone brushing up on CNN, I hope you find this tutorial helpful. If you enjoyed this video, please give it a thumbs up and don't forget to subscribe for more hands-on coding tutorials. Let me know in the comments if you would like to see more advanced topics like transfer learning or object detection. Thank you for watching, and as always, happy coding.